For this function, we're asked to find the net area under the region of f of x, and we're on the interval from 1 to 2. So if we want to find the area or net area, we want to remember that's a regular integral. So we are going to set up our own integral from 1 to 2 of x squared plus 5/3 over x cubed plus 5x all squared, and we'll put our dx in there. So all we're doing is we're having to set up our own integral given a function and the interval that it's on. So this looks like a quotient rule for taking a derivative, which means for taking an antiderivative, we're going to use u sub. We're going to call u x cubed plus 5x, the denominator's expression, and then the derivative of x cubed is 3x squared, the derivative of 5x is 5, and then we're going to pull up that dx. We're going to multiply both sides by that to get du by itself. And then last thing we need to do before we do our substitution is to change our bounds. In terms of x, we were going from 1 to 2. So we're going to figure out what is u when x is 1 and what is u when x is 2, and we'll find that by plugging into u here. So u is going to be 1 cubed plus 5 times 1, which will give us 6, and then 2 cubed plus 5 times 2, which will give us 18. Now we can do our substitution step, changing this integral all in terms of u. So in terms of u, we're going to from 6 to 18 with our bounds. U is in the denominator. Automatically, that's to a negative power. Every quotient rule makes it so that we have a negative exponent. This is u to the negative 2. There, we've subbed in for the whole denominator. Everything left over, I want to make sure I have a perfect du with. So for a perfect du, I need a 3, an x squared plus 5 dx. I have an x squared plus 5/3 dx. So I have a 1x squared where I really need a 3x squared. So I could say I have 1/3 of my perfect du. That would be the non-visual way, is just seeing what number you have off without actually seeing it in there. We could do it the visual way as well. By putting a 3 in there, I would get 3x squared plus 5/3 times 3 is just going to be 5. So I'd get 3x squared plus 5 dx, exactly what I need. I'd get my perfect du as long as there was a 3 inside. And to balance it out, we'd put a 1/3 outside. In other words, we had 1/3 of our perfect du when we had that x squared where we needed a 3x squared. So I'm going to keep that 1/3, and I need to remember to take the antiderivative now. So negative 2 plus 1 is negative 1. So I'm going to do 1 over negative 1, u to the negative 1, and an evaluation part instead of a plus k. We're going to evaluate from 6 to 18. I could multiply these fractions together to get a negative 1/3 outside. And do 18 to the negative 1 minus 6 to the negative 1, plugging in my upper bound minus my lower bound. Most calculators, you might need to put that negative 1/3 in its own set of parentheses, since it is a fraction. And then we're plugging in our upper bound minus our lower bound. So it would be about 0.037. And then it's also repeating, or about 0.04. An exact answer would be, if we hit math enter, enter, F arrow D, we would get 1 over 27 as the exact fraction, or as an estimated decimal, we could say 0.037 or 0.04.